right, hello. These are the 7.6 notes, inequalities in one triangle. So a couple things to note here. This activity in class we did alongside a Desmos activity. So if you're looking to do both of those, make sure you pull the Desmos activity up at the same time. And the other thing is that there are a couple of typos on here that I have not been able to fix on the old copy of the notes. So if you're accessing this old copy, just know that there's going to be a couple of small things to change. So one feature of triangles is that the largest side is across from the largest angle. So if angle C looks like my biggest side to me, let's put LG for large, then that means it's across from my largest side. Now, I did make a note over here, capital letters are for vertices and angles, and side B or side AC would be talking about like the same side. So for example, across from capital C is lowercase side c, but I also call this side AB, okay? In this case, I have a small letter. In most of the other cases, you won't see small letters. So just to be clear, all right? So my largest side is side AB. And then similarly, the smallest side is going to be across from the smallest angle. So let's guess here that angle B is the smallest one. All right. That means that the smallest angle is B, and the smallest side is going to be this little side over here, which I could call lowercase b, or I could call AC. All right. And that means that the other one's going to be the middle, right? So this is going to be the mid, and this will be the mid-length side. So if I have angle, which one did I say was smallest? Angle B is smaller than angle, the medium one is going to be angle A, which is smaller than, the largest one is going to be angle C. So if angle B is the smallest angle, then across from that's the smallest side. So AC is going to be less than angle A is across from BC, which is less than the largest one. So largest angle is C, largest side is AB. All right. This could also be written as B is less than A is less than C, all right, for lowercase letters. Example 1, write the sides in order of shortest to longest for triangle DEF. Well, I have two angle measurements. I have angle E is 115 degrees and angle F is 28 degrees. In order to know which one is the smallest, I need to find angle D. I can tell you right off the bat that E is going to be the largest, right? 115, there's not going to be anything bigger than that. But I need to find the other angle. So what do we know about the interior angles of a triangle? We have a sum of 180 degrees. So let's figure out how much I'm missing. So 115 plus 28 gives me 143. I subtract 143 from 180, borrow from the 7, and I get 37 degrees. So 37 degrees is going to be the middle one. All right. I want the sides in order from shortest to longest. So which is my shortest side? My smallest angle is 28 degrees, so that's going to be across from my smallest side. My middle angle is 37 degrees, so that's going to be across from my middle side. And then my largest angle, 115 degrees, which angle E, is going to be across from my largest side, like that. Shortest to largest, talking about sides, good. Now, close reading here is going to be important because the next problem asks me for the angles from largest to smallest. And there's a little bit of a detail in here that we've got to pay some close attention to. So I have this triangle QRS, and you'll see QS is 2 feet, QR is 30 inches, and SR is 18 inches. Well, I've got different units going on here. I've got inches and inches and then 2 feet. So instead of 2 feet, I can either rewrite that as inches. So there's 12 inches in a foot. So this is going to be 24 inches. So I need to take that into account before I start anything. All right, I want the largest angle. So where's my largest side? Largest side, largest side. So this is my largest side. So it's going to be across from my largest angle. So angle S is going to go first. My medium length side, right, is 24 inches, and that's going to be across from my medium length angle. And then my medium length, or my smallest length side is 18 inches. That's going to be across from my smallest angle. So largest to smallest angles. Got it. So you may want to highlight this or underline it. Triangle inequality theorem here. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Consider this. Let's say I have some sticks, and one's 6 inches, and one's 2 inches, and the other one's 2 inches. Do you see how it's impossible for the 2 inch and the 2 inch to meet while still touching 6 inches? Right? They wouldn't come together at a point. Same thing would happen even if it was 3 and 3 and 6. If I had 3 and 3 and 6, 3 and 3 would make a line. It wouldn't leave any space in between. So when I have a triangle, any two sides have to be greater than the third side. So in this example here, I would say that A plus B has to be greater than C. A plus C has to be greater than B, and B plus C has to be greater than A. Can a triangle have the given side lengths? If not, why? So for A, I've got 10 yards, 12 yards, and 15 yards. So I have to check. Is it true 10 plus 12 is greater than 15? Is that true? Yes. Is it true that 12 plus 15 is greater than 10? Yes. What's my other combination? 10 and 15 is greater than 12? Yes. So since that's true, yes, it is a triangle. Now in reality, the only one you have to check is the smallest two. So this is going to be your key right here. Do the smallest two add up to be greater than the third one? Which makes sense because is 12 plus 15 greater than 10? Yeah, 15 by itself is already greater than 10. Is 10 plus 15 greater than 12? Yeah, 15 by itself is already greater than 12, right? So if you just check the smallest two, that'll give you an answer. So for my next one, I check. Is 5 plus 6 greater than 11? No. It's equal to. And equal to does not form a triangle. So no. 5 plus 6 equals 11 when any two sides added together must be greater than the third side. If you needed some evidence here, you could honestly take something and measure it out in centimeters or inches, like a straw or a stick or a piece of paper or something, and you could try to draw and make a triangle with that, and it just wouldn't work. So for 4, a triangle has side lengths 6 centimeters and 15 centimeters. What are the possible lengths of the third side of the triangle? So I'm going to give you the longer explanation here, and then I'm going to show you kind of how to trim it down. So here we go. I have some other side. I'm just going to call it x. All right. So I know that 6 plus 15 must be greater than x. I know 6 plus x must be greater than 15. And I know 15 plus x must be greater than 6. Well, now check it out. 15 plus x is greater than 6. Well, automatically, because 15 is already greater than 6, so we can ignore that. So what I'm left with here is I've got 6 plus 15, so that's 21 must be greater than x. And then here, if I subtract 6, I'm left with x must be greater than 9. So the third side is greater than 9 and less than 21. Or you could say the third side is between 9 and 21. And let me include my units in here. 9 and 21 centimeters. The 9 and the 21 just come from adding these two numbers and subtracting these two numbers. So if I do 6 plus 15, I get 21, and if I do 15 minus 6, I get 9. All right? That's what two numbers it's going to fall in between. So pause this and look at example 5. First of all, a triangle has side lengths 15 millimeters, and this should say 30 millimeters. There may have been an error right here. Yours might say centimeters. What are the possible lengths of the third side of the triangle? So pause and figure that out. All right, so all I'm going to do to figure this out is I'm just going to add and subtract. So what is 15 plus 30 gives me 45. That's my upper bound. And then 30 minus 15, always subtract the smaller from the largest. I get 15. So the third side is between 15 and 45 millimeters. Right? Or it's greater than 15 millimeters and less than 45 millimeters. Example 6, which of the following are true? Select all that apply. So I'm going to ask that you pause again and go through this list and just do the best that you can. Please note before you start that F, there may be a typo right here. Should have an A right here. And when I originally made these notes, I mistyped and put a C. So just double check that. Okay, pause and take a look at these answers. Okay, so looking at these answers, let's go through one by one and try to assess. AB is equal to AC. AB is equal to AC. The only way that that could be true is if the angles across from each other are equal, right? So I don't know if these are equal yet. So across from AB is C. Is that the same as what's across from AC, which is B? So is this the same as 48? I don't know. Let's see if we can figure that out. So again, the interior angles of a triangle must add up to 180 degrees. So I'm going to do a little bit of math here to figure out that other angle. And I get 62. All right. So are these two equal? No. That's false. B, angle BAC, so BAC, tracing this angle BAC, is greater than ABC. ABC. So to color coordinate things here, make my life a little easier. So is BAC, I just traced it so that I got the right angle, is greater than ABC. Yeah, 70 is greater than 62. So I'm going to say that yes, this is true. C, is AB greater than AC? So AB is this side here. And then AC, over here. AB is across from 48. AC is across from 62. So which one has to be bigger? The one across from 62, the AC. This says it's smaller. So this is going to be false. D says, okay, is it true that AB is smaller than AC? And the answer here would be true for the same reasons, right? So the bigger side, AC, comes across from the bigger angle. 62 is bigger than 48. All right. E says AB plus AC is greater than BC. And that's just naming these sides, right? AB plus AC is greater than BC. And we know that that must be true, right, for any triangle. Any two sides have to add up to be greater than the third side. And then the last one, are these in decreasing order? So how big is angle C? That's 48. Angle B is 62, and angle A is 70. That looks good. That looks true to me. All right. And this wraps up the 7.6 notes for today. Thank you, and I hope that you are safe, happy, and well. Bye-bye.